We now discuss the solution of a problem from the section Probability and Statistics. The given problem is related to the variance of the given data. This question has appeared in the Joint Entrance Examination Main held on 29th June 2022 in the second shift. The given question is the number of values of A belongs to n, the set of natural numbers, such that the variance of 3, 7, 12, A and 43 minus A is a natural number is, we are given four options. Option A, 0. Option B, 2. Option C, 5. Option D, infinite. We are given the data 3, 7, 12, A, 43 minus A. And we have to find the number of values of A that belong to natural number such that the variance of this data is a natural number. So we have to find the number of values of A belongs to n such that the variance of this data is a natural number. Let's now discuss the solution of the problem in detail. We have the given data, and these are the 5 observations consisting of 3, 7, 12, A, 43 minus A, where A belongs to the set of natural numbers. And its mean, denoted by x bar, is the sum of the observations by the number of the observations. That will be 65 by 5, that is equal to 13. Now we calculate its variance. Its variance is given by the sum of the squares of the observations by the number of observations minus the mean square. And when computed, you will get this one. And we simplify. We further simplify and we get ultimately 2a square minus 86a plus 1206 by 5. And in the numerator, 2 is common. We have taken 2 common in the numerator. And then we write it as 2 by 5 into a square minus 43a plus 603. What is our question? The question is required to find the number of values of A belongs to n such that this variance is a natural number. When this variance is a natural number? If a square minus 43a plus 603 is a multiple of 5. Natural numbers multiplied by, this is 5n, where n is a natural number. So now variance is a natural number if a square minus 43a plus 603 is a positive integral multiple of 5. That is 5 times n, where n is a natural number. That is a square minus 43a plus 603 is a multiple of 5. That is 5n, where n belongs to n. Now this implies we have a quadratic equation in A, that is a square minus 43a plus 603 minus 5n, where n is a natural number. We continue in the next slide. So we have that quadratic equation in A, where n is a natural number, and when solve this quadratic equation, we get A is equal to minus b plus or minus under the square root of b square minus 4ac by 2a. Right? 2a. When simplified, you will get a is equal to the roots of this equation. A is equal to 43 plus or minus under the square root of 20n minus 563 whole by 2 into 1, that is 2. Right. So the values of A we got it, and our question is for the number of values of A which are natural numbers for which the variance is a natural number. Agreed. So now A is a natural number if two conditions are satisfied. The first condition is 20n minus 563, that is the discriminant of this quadratic equation, is a perfect square. First condition. And the second condition is 43 plus or minus under the square root of the discriminant by 2 is positive integral multiple of 2. It should also be this should be an integral multiple of, positive integral multiple of 2. That means it also turns out to be a natural number. Agreed. Let's now examine the first condition, that is 20n minus 563. Is it perfect square? Observe that 20n minus 563 is a negative if n less than or equal to 28. Right? You can verify this. And if n greater than 28, that means if n greater than or equal to 29, then 20n minus 563 is positive, and the units place, if you see, for this 20n minus 563 is always 7 for n greater than or equal to 29. So the digit, so 20n minus 563 when n greater than or equal to 29 is positive, and the digit in the unit place of 20n minus 563 is 7 for any n greater than or equal to 29. You can see, you can put 29 and subtract, you will get, is always a 7. Suppose you have a natural number whose units place, which is 7 in the unit place. Can it be a perfect square? So it is known that any natural number which has 7 in unit place is not a perfect square. So that means this 20n minus 563 is not a perfect square. So when you compute A, then A will not be a natural number. So therefore A is a complex number if n less than or equal to 28. Yes. Why? Because n less than or equal to 28, a 20n minus 563 is negative. So the square root of negative is a complex number. So A is a complex number if n less than or equal to 28. And when n greater than or equal to 29, this 20n minus 563 always ends with 7. Therefore, it cannot be a perfect square. Therefore, A is not a natural number. It can be a rational number. Not a natural number, but a rational number. Not a natural number, but maybe an irrational number. So, in any case, A is not a natural number for any n greater than or equal to 29. So, now from this, A is not a natural number in any case. So, thus A is not a natural number in any case. So, let's now answer our question. The number of values of A belongs to the set of natural numbers such that the variance of this data is a natural number is 0, because A is not a natural number. Agreed. So the number of A belongs to n, now satisfying the condition, is 0, because A is not at all a natural number. Now let's look at our options. Our answer 0 appears against option A. Therefore, the answer to this question is option A. That is the detailed discussion of the solution of the problem from the section probability and statistics. And the question is related to statistics, and it is related to the variance of the given data. It is definitely difficult question, because drawing conclusions that there are no such natural numbers will be the crux of the problem. So I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.